Hello, everyone, once again. And for the people who are joining in the last few minutes, I just want to mention that we will allow a few minutes of questions at the end of this presentation. So if you have something that you want to have clarification, you can just keep the question in your mind, or you can just paste it in the chat in this meeting. So we will go over the questions at the 10 or 15 minutes by the end of this presentation. Okay, so if everyone is ready, let's start. Today, as we mentioned, we are going to talk about how we can optimize costs in the cloud. And to mention once again, my name is Dima, and I'm working at WideOps for more than 3 years now. I work mainly as cloud solution architect, but I'm also working as a FinOps practitioner. And today I want to share with you some of the tips and tricks that we have on how we can optimize and visualize the costs in the cloud. So with the scalability of the cloud, companies that are moving from on-premise environment had to adapt to the new pricing model. Because in the cloud, the invoice at the end of the month is no static anymore. Because the cloud is working with in the pay-as-you-go model, we can basically have unlimited scalability, and we can provision as much resources as we want. That's a completely different approach in terms of calculating the costs and our budgets through the year. And it's one of the benefits that the cloud provides, but on the other hand, it also needs to be considered while we are allocating our budget for the next coming year. Now, the main goal was always to find the right balance between the cost efficiency and the productive and a scalable business. People use different methods to reach that goal, but implementing cost-efficient approach was not an easy task. So around the year 2019, the FinOps Foundation was established, bringing together thousands of experts from various companies to share their experience and knowledge. And today, the FinOps approach can be used across all services in the cloud, but today I want us to focus on the Google Kubernetes Engine. In our presentation, we will go over 3 main stations, which is discovering, optimizing, evaluating, and at the end, repeating all over again. Now, in the current station, which is the discovery, we need first of all to understand what are we paying for and how much. In Google Kubernetes Engine or GKE, we pay for the resources we request rather the resources we consume. Now, Google charges per compute resources like CPU, RAM, disk storage, and egress traffic. To filter out the compute resources that are not part of our GKE cluster, we can use labels. We can label our cluster and review all its related charges. I want to mention here one thing, that GCP labels and Kubernetes labels are completely different. Now let's see how it's done. We can label our new or existing clusters simply by setting the label key and the label value in the metadata section of our clusters. Or we can use the default labels that Google applies automatically to cluster resources. Here are some of them. We have the Google cluster name, we have the Google cluster location, and we have the Google cluster node pool name. Both the manual labels and the default labels are inherited to the VM instances and to the VM instances and to the attached persistent disks of those instances. So if we have a node pool labeled with specific label, those labels are inherited to the VM instances and to the attached disks of those instances. Now, in the billing console, we can see the charges that are associated with our manual cluster labels, the default cluster labels, and the default node pool label. We can see the charge that is generating our cluster, which in our case is called cost optimization. Those labels are fully our choice. We can label it as in any way we want, except the default labels which are predefined. Now, but what if we want to drill down and review charges per namespace or per pod, for example? Because getting the charges per cluster or per node pool is not always enough. Now, the first option that I want to talk about is the GKE cost allocation. The GKE cost allocation provides new and simplified alternative to the GKE usage metering. It provides the cost visibility on the cluster, namespace, and even the workload level. Now, to use this feature, we need to do two things. The first one is enabling the detailed usage cost export, which is located on the billing export page on our billing account. The second thing we need to do is enabling the cost allocation feature itself on the cluster. You can see on the screenshot attached where we have the cost allocation option enabled and the billing export. In the billing export page, the detailed usage cost is enabled as well. Now, once those features enabled, the data is available in the billing console in the form of label key and the form of label values. We can filter and display the charges that are related to our namespaces and workloads. We can see on the left side an example where we can see the charge that is associated with the namespace called cost optimization. And on the lower part of the screenshot, we can see another example where a specific application, or in this case, a Jenkins POC pods that were generating this amount of charges. This visibility allows us to get much more detailed breakdown besides the knowledge that we have how much our cluster is generating and how much our node pools are generating. Now, the charges that we see here are combinations of GPU and vCPU SKUs, RAM SKUs, and persistent disk storage SKUs that are requested by the namespace or the pod. Additionally, we have a few logical namespaces that are presenting the resources that are reserved for system overhead, such as kubelet or Docker daemon, or resources that are unallocated at all, means that they are not requested by any workload. For people who want to have more flexibility or more visibility into the costs insights, we can query the exported billing data using the BigQuery. We can do it using the example queries Google provides. And for example, I want to get the charges after credits per each namespace. I can use this specific query and I will get this result. Now, what if I want to list and find the top 10 cost-generating SKUs in my cluster? In this example, I can use this specific query to get the results as well. Now, we can also integrate BigQuery with Google's Looker Studio, which comes in the free edition, and the Looker Studio Pro in the paid edition, and create dashboards based on custom queries and business logic. For example, we can label our resources with an application or customer labels and get insights on costs of running it. We can see in the example that in this case, I used labels of customer 1, customer 2, and customer 3 to represent the namespaces that are hosting the resources of those customers. All we need to do to generate a report is enter to the Looker, is going to the Looker website, which is lookerstudio.google.com, and create a new data source. Data source in Looker Studio is like a table in BigQuery or in other SQL. We can just paste there our query and click on create a report. Those are 3 simple actions that we do to create our report. Now, I want to summarize and mention a few important notes regarding the cost allocation. The GKE cost allocation feature itself doesn't cost us anything, but it may increase our BigQuery storage and querying costs. It depends on the amount of data we store and the queries we execute. The second one is that we must enable the detailed usage cost export to view the namespace and pods cost and data. It's important to note that the previous labels that I mentioned, which are the cluster name, cluster location, and node pool name, are visible regardless if we enable the detailed usage cost or not. The third one is that the GKE cost allocation data is based on resource requests and not resource consumption. In other words, we can see the costs of our resources we can see the costs of the resources our pod is requesting, but not how much our pod is actually using. Now, for me, when I was starting and using this feature, I didn't like this option, because for us to get a waste percentage, for example, or get the estimation of how much our workloads are not utilized, we need to know how much our pod is actually using. Now, this might not be a critical fact for everyone, and some people might just want to visualize their costs. But for me, I had to have the metric of how much my pod is actually using. Now, the second option is the GKE usage metering. The GKE usage metering tracks information about the resource requests and the actual resource usage. Now, similarly to the cost allocation, the GKE usage metering tracks information about CPU, GPU, memory, storage, with the addition of TPUs and network egress. Now, compared to the cost allocation, it involves more steps in the initial setup, but provides the visibility only on the BigQuery level, or the Looker integrated reports, of course. But this is the right choice for use cases where we want to identify workloads that can be optimized. And the main difference between GKE cost allocation and the GKE cost metering in terms of how it works is the GKE cost allocation inserting the cluster's data into the billing data, and it's all aggregated in one place. The GKE usage metering, on the other hand, is extracting the billing data and the cluster data into two separate BigQuery tables, and then aggregating it into a third table, which we use to visualize our data. Now, there are four main steps to enable and use GKE usage metering, so let's see how it's done. The first step is to enable the standard usage cost export on the billing export page on our billing account. The second step is to enable the GKE usage metering option itself on the cluster level. And the third one is to create a scheduled query that will aggregate the billing and the consumption data. Now, the full query and the variables are available in the documentation, but I want to specify here. I want to mention here three specific variables that we use. We have the billing export table, which is the first table where our billing data is stored in BigQuery. The second one is the usage metering dataset ID, which is the second table where our cluster's data is going to be stored. And the third one is the third table, which stores the aggregated data from the cluster usage consumption that is being translated into the costs using the billing table. Now, similar to the cost allocation step, we can enter to the Looker Studio website and create new data source, paste our query, and create a report. Now, let's see an example of this report. The reports are fully customizable and allow flexibility to adjust to a lot of scenarios. Google also provides a report template that we can copy and create our own reports with one click, basically. On those charts, we can see the cost breakdown per workload, namespace, department, cluster, and the requested and the consumed and unutilized cost. We can also review the amount of unallocated CPU and RAM per namespace or workload. Now we can see in those charts that are generated customly and partially are also available in the default template. But again, they are fully customizable and they can be integrated with any business logic that you want to display the information that is relevant to the company that we're working with. Now, in the first example, we see the namespace, department, cluster name, which are also can be set as labels, and we can then extract them and review the costs of the requested resources, the consumed resources, and the unutilized resources, and the waste percentage that is caused because of wrong allocation. Now, in different scenarios, there are different results because sometimes we allocate more resources than we need in an advance because we have, for example, some Black Friday event, and we don't want us to have any shortage of resources. So those reports does not provide the exact steps of what we can optimize, but rather it's providing us the visibility for us to then make the decision ourselves. Now, I want to summarize and mention a few important notes regarding the GKE usage metering itself. The GKE usage metering tracks information about the resource requests and the actual resource usage of our cluster workloads and potentially egress as well. It involves more steps in the initial setup, but provide valuable information for cost optimization. And only label from pods are tracked. So for example, no deployments or other controllers are tracking the usage. Now, when we know how much we pay and for what, we can move now to the next station. Now, when it comes to optimization, it's a good idea to start small and pick up the money from the floor, as we call it. From the technical perspective, we can use the cost avoidance practices, for example, avoid over-provisioning and ensure that our nodes are sized correctly to our workloads. The second one is to use GKE auto-scaling. Check if scaling profile can be set to optimize. For intense egress pods, consider locating them in the same zone to avoid higher rates of egress charges. From the pricing perspective, we can use the cost reduction practices and, for example, consider a yearly commitment for CPU and RAM to get a better pricing. If possible, we can use spot node pools, which provide up to 90% discounted cost. And if allocation of our workloads is not a factor, we can place them in the cheapest region. Now, additional step in optimization is to allocate a budget and optimization goal. Now, we can do it per project, per cluster, per team, per application, whatever makes sense to the business. Setting budget can be done from the billing console in the budget and alert section of the page. The main parameters of the budget settings are time range, which can be monthly, quarterly, yearly, or we can choose a custom range. And the scope. The scope can be one or more projects, one or more services, or one or more labels. We can also make a combination of projects and labels, services and projects and labels. Now, when I say labels, I'm meaning that all labels, which including for example, the Kubernetes cluster name that we previously mentioned, or manually assigned as the cluster label that we also mentioned before, or even the label of the pods themselves, we can use them to set up those budget alerts. The budget alerts are used only as alerts, but we can also integrate them, for example, with PubSub and connect them to a cloud function, and the cloud function can actually perform actions based on those alerts. For example, if we have a dev environment and we set up budget of specific amount. Now, when this specific amount is reached, we can trigger a pub/sub that will trigger cloud function that will stop or delete all the instances in this project. Now, setting optimization goal is also very important. Optimizing without adjustable success criteria is probably not the best method. Now, to set this goal, we need to use multiple levels and understand what we want to achieve. Do we want the end result to be 10% off and we don't care where did it came from? Or do we want to optimize only the dev workloads? Or maybe we want to optimize specific team or specific application workloads. Going back to the labels, we can label our resources based on business logic that we choose. For example, we can apply to our workloads or resources the following labels. We can use team, component, environment, or state. Now, for team, we can set, for example, the label value to be research, to show that those resources that are labeled with research label are actually for research and not for production and can be terminated if needed. Now, for component, we can say, for example, our component is Redis. And we know that that resources that containing the Redis label are not something that we can terminate because of shortage in our budget, because they're crucial to our production workloads. Now, for environment, we can set, for example, test label. And we know that for testing, we can terminate the resources if we don't need them. Same for state. State can be, for example, labeled on disk resources snapshots, and we can label them as ready to delete or in use or attached to understand which snapshots or disks we can terminate or we need to leave them for compliance or because they're just being in use. Now, it's also important to know that we want to make sure to have much labeled resources as possible and cover maximum of the cost generating workloads, but also to make sure that the label strategy we use is making sense to us and to the people we're reporting it to. Now, our final evaluation stage is the stage where we evaluate the progress and the coverage of the labeled resources. It's important to notice that manually labeling all existing resources or manually tracking all of the newly created workloads, it's not an easy task. Every evaluation, we can go over the current progress and see where we can improve our visibility and automated labeling strategy, including replacing hard-coded pod templates with dynamic templates that include the needed labels for each use case. We shouldn't forget that spreading the shared responsibility across team and colleagues, and also reward teammates who show progress in optimization of their workloads. It's important to share the optimization process with the whole company and encourage others to join the effort and move cost discussion to the beginning of the development process. Remember that cost optimization is more just than saving money. It's also fully developed culture. Businesses adapt to reach their full potential. Now, it's important to understand that this process, those 3 steps that I mentioned, are not something that we start and finish. This is something that is always evolving. We need to repeat this process all over and over again, and this is why we have the evaluation step. Now, this is the ending of the dry presentation, as I call it. And I would like to hear some real use cases or real world scenarios that people might have and didn't got the chance to ask or to find a solution for it. Do we have any questions or specific use cases that you want me to address or provide you some more examples, for example?
Dima, I have one question regarding the regions or location of the cluster. You mentioned your slides that we can choose the cheapest region, but
Yes.
how to determine this?
We have, Google has a pricing page. For example, if you're running a GKE cluster, I assume, let's assume GKE cluster. So the GKE is actually running compute resources, right? The node pools. Now, for node pools, we're paying per CPU and per RAM. Now, each region, if you will look in the pricing page, each region you can select, there is a drop down that you can select regions, and each region has slightly different pricing per CPU hour. So you can go to this pricing page, select the cheapest region if it's not
Yeah, but
crucial.
how to know it's I don't want to go over all the regions. Just give me the cheapest, you know.
There is no option to automatically select the cheapest region. You need to do the research.
Okay.
But really, there is Google has a lot of regions, but this is not something that will take more than a few minutes to understand which is the cheapest one.
Okay.
Now, same can go to the point that I mentioned that if, for example, it's not an availability requirement, so we can put our nodes in the same zone, because pods that communicate between nodes that are in different zones generating charges of egress traffic. But when the traffic is on the same zone, so the charges there are the lowest that you can pay for egress traffic. Is anybody has started or working with some FinOps approach, or started labeling their resources, started to get interested in this topic at all? Okay, so
Um,
for,
just one more question, a little bit of topic regarding the labeling. Is there any automatic tool that can provide me with labeling all the current resources?
it is semi-automatic. You can use a cloud function. You understand? You need to understand why it's semi-automatic, because Google cannot decide for you your business logic, and the labels are partially. We put labels partially because it will help us to get visibility and cost breakdown per our own logic. So, for example, if we're talking right now only about GKE, so basically when you apply label to a cluster, it inherits the labels to all cluster resources. So if this is your question, so yes, we can call it automatic, and we don't need to do anything to achieve it. We just label the cluster, and all cluster resources are being labeled with the clusters label itself. Now, Google also providing, Google launched recently something that called FinOps Hub, and it's located in the billing section of the Google Cloud Platform. And in the Google Cloud Platform, in the FinOps Hub section, we can actually go and see our FinOps maturity, as it's called. So we can actually get a score of how much of our resources are labeled, or where we can improve, what we can label, and basically just get a rough estimation of how we are proceeding with this FinOps approach that is becoming very popular now, because once you will start using it and you will start to get this visibility, especially in big companies, but not only big companies, small companies can leverage it as well, because as long as we starting small and we grow with the time, starting at the beginning, it is much more important and easier than starting to do it when you are with a big amount of resources and a big amount of VMs that you need to go over and label them manually or semi-automatically or automatically if we are talking about the GKE cluster itself.
The strategy that you mentioned also referring to autopilot model, or
yes, autopilot is also supporting labels, but they're less flexible. So they're also inherit the main cluster labels, but you cannot assign manual labels as you can do on the standard cluster.
Okay.
So I personally find the GKE usage metering itself very useful to understand not only the difference between the allocated resources and the consumed resources, but also how it looks like in terms of money. So for example, I believe that a lot of people using Datadog, for example, or Google Metrics to understand how much they're allocating and how much it is not utilized. But when you see the dollar sign, it's completely different. Now we have a question in the chat, which is asking, is this solution is only for GCP? Now, this solution is not a solution, it's more than approach. And I'm talking about the FinOps approach. So it's not GCP exclusive, but in GCP, we have our own tools to help us achieve this goal. So again, we have the FinOps hub, which is GCP exclusive. We have the labeling behavior, which is GCP exclusive. I mean, I believe other providers has it as well, but they all might have different behavior. For example, I know that the GKE usage metering and the way it's aggregating the usage and translates it to cost is something that is exclusive to Google. The committed use discounts, analyzer, and recommendation are not specific for a GKE cluster, so it might be slightly off topic, but Google has those recommendations and Google has those metrics, and we can just go and see the recommendations. It is also available in this FinOps sub that I mentioned before. We can see literally the list of the amount of money that we can save by purchasing specific commitments in specific regions, and so on. If someone is interested to ask questions that is not GKE specific and there might be more interested in something that is broader than GKE, so again, feel free, we can discuss things that are off topic as well. So if we are going to talk off topic, we can talk about, for example, the same label strategy. No problem. I will share my email at the end of the presentation. Everyone who might have more specific question or is interesting to have a conversation one-on-one and just get more clarity, no problem. You can reach, of course. So in regards to the off-topic resources, which can be, for example, Cloud SQL instances, or for example, BigQuery tables, there also can be labeled. So this is not something that is GKE or instance specific. The main goal of the FinOps is, first of all, is to save money, right? But the second goal is, and the not less important goal is to get visibility to what we have. So for example, I had a customer that is running, I think, 60 projects, and they have around 400 clusters. So just imagine to yourself that you need to go and start analyzing each and one of them. Now, the first thing we did was to label everything. Label the VMs, label the GKE clusters, label the Cloud SQL instances, label the BigQuery tables, label the functions, label everything. Now, once we got the first visibility, we understood that we found 15% resources that we were not even been aware that they're existing. So, for example, there was one project that was testing project, dev project for the DevOps team. They created a cluster 5 months ago, and it was generating something around $150 per month. And for a big customer, those amounts are getting erased, because once you have big spends, those little ones are getting overridden because they're just too small. You don't see them. So using the labeling and reporting, we were able to find that they can save this $150 per month, and it's only for one cluster for one project. Now, again, it doesn't matter if you're a small company or a private customer or a big company. We can use this approach across all scales, and it will only do better for your visibility and understanding of what we are actually paying. And I also mentioned that we can leverage commitments, and this is also something that we can use not in the FinOps specific area, but we can just go to the recommendation. We can see the recommendations Google providing, and we can decide if we can commit to those resources for periods that it's for 1 year, for example. If our business is stable and we can commit to 1 year, why not? We can have discounts. We can get something like between 20–30% discount per CPU hour. Why not to leverage it? But if we're not going to take any action, we're basically going to keep the situation as it is. We're not going to save more than we know that we're going to save. But the FinOps approach is giving us much more broader approach of how we can come to this problem in the first place. Now, again, I think that the FinOps approach is really more than just an approach and labeling schema. It's really a culture. Okay, so once you're starting with it, you're starting to work and invest, it will get back to you and it will save you a few dollars here and there.
Dima, at the beginning, you mentioned that we should use labels and not tags. Can you clarify that?
I didn't mention that we shouldn't use tags, but tags are used for different purpose. Okay, tags are used for mainly for firewall rules or routing tables. So tags is also a way that we can tag resources, but this is not for cost allocating purposes. In Amazon, tags are labels in Google, so it might be confusing to someone, but
yeah.
in Google, tags are completely different section, and it's not related to cost.
Got it. Thanks.
So I see no more questions here. I don't know if this is because you're not familiar or might be not started this process, or I don't know, but I want to mention once again that if you're interested in maybe to have a more four eyes conversation, maybe discuss specific use case, or maybe you have a specific question that you are willing to share, not in this forum. So again, please feel free to reach me or WideOps in general, and we'll be happy to assist you in any way we can. Now, we will send you a summary email with the link to the webinar recording, and if someone is interested, again, my email will be included there. And any further questions, we can discuss it there, and we can schedule a meeting with me or any other WideOps representative. If it's technical question or if it's pricing question, we will find the right person for you to address the issues. And I want to thank everyone for coming and joining. Thank you for your time. It was a pleasure for me to have you. And thank you once again, Google Cloud and Israel Cloud, for making this happen. Thank you for your support and environment. And again, I wish you all a good and safe week. Thank you very much.